Hello viewers, welcome back. Sometimes you might be required to find the length of a tangent to a circle from an external point. However, this point will still be within the plane at which the circle is. So let's consider a circle on a coordinate plane. But first, let's have the coordinate plane. So if this is my coordinate plane, where this is the y-axis, and that's the x-axis. We have the negative y-axis and we have the negative x-axis. So the axis at this time is irrelevant. We really don't need to pay attention to that. So if a circle is on this plane, take for instance, we have a circle here. Perfect. Now a tangent to this circle, that will be somewhere around there to the circle. Okay. Now, this point, notice that it will definitely has its own coordinates. Let me use a red color to mark it. This point that the tangent ends, it will have its own coordinates. Let it be x, y. Perfect. Now, if this is the center of the circle, it's not in news that the radius of the circle will be this way. And we can always have the magnitude of the radius of the circle using the equation of the circle. This circle is not centered at the origin. So definitely it will have its coordinates of center. So the coordinates of the center C, let it be h, k. It means that the equation of this circle will be x minus h all squared plus y minus k all squared equals to r squared. So if you can have this circle, if you can have its equation in this way, then whatever we see here would be the radius of the circle, and we can use it as the magnitude of this red line. Perfect. Now, since a tangent line is always a straight line and radius is also a straight line, can we just join these 2 points, the center of the circle and this external coordinates outside the circle but within the plane? So let's join it with a straight line as well to the center of the circle. Notice that a right angle triangle has now been formed. And this is a right angle triangle, okay? Oops. So a right angle triangle has been formed. Now, the goal is to find the value of this length from here all the way to this point, because that will be the length of the tangent to this circle from this point. You understand? That's how the question will come. Find the length of a tangent to the circle, then you've given the equation of the circle, then you've given the external point at which the tangent length is expected to be formed. So let's assume this length is t, length of tangent. This one is radius r. This yellow line, its distance can be determined using the distance formula. As you can see, we have the coordinates c and we have the coordinates x, y. So if I call that length, the length of the yellow line, let it be p. Notice that p would be equals to the square root of the difference between this stuff. Okay, let it be x minus h all squared plus y minus k all squared. So that will be the value of p using the distance formula. So once we have p, we can definitely have t using Pythagoras theorem. We know that p squared would be equals to t squared plus r squared. So definitely t squared, which is the length of the square of the length of the tangent line from that external point x, y, will be equals to p squared minus r squared. And this is what you'll be putting into account whenever you want to find the length of a tangent line to a circle from an external point. First and foremost, find the radius of that circle. Secondly, the center of the circle. Now use the center of the circle and the external point given to you, use it to find the value of p. Once you have p and you have your radius, square each of them, then find the difference between them. That gives you the length squared of what you are looking for. Then at the end of the day, just find the square root of your answer and boom, you are good to go. So technically, the length of the tangent line to the circle from x, y would be the square root of p squared minus r squared. And that is how to find the length of the tangent line. Now let's put this into practice and see how it works. Example number 1. Find the length of the tangents to the circle x squared plus y squared minus 2x minus 4y minus 4 equals 0. from the point 8, 10. Now, as you can clearly see, the equation of the circle is given in general form. Now, to find the coordinates of the center and the radius, we must be able to express this general form equation into the standard form, because in standard form, we can easily figure out the center and the radius. So let's write the equation. Let's begin the solution. So we have x squared plus y squared minus 2x minus 4y minus 4 equals 0. So to write it in standard form, we need to complete the squares. First, let's attach similar variables to themselves and then separate constant from them. So therefore we have x squared minus 2x plus y squared minus 4y equals to 4. When this leave the space and comes to the side, it becomes 4. Good. So let's complete the square for x terms first. So we take the quotient of the linear term 2, we multiply by half and then square our result and add it to both sides. Notice that 2 cancels and we're left with 1 squared. So the goal is to add 1 to this side, likewise this side, and that's it. So therefore we have x squared minus 2x plus 1 plus y squared minus 4y equals to 4 plus 1. Well, it's just that the visual illustration of this equation has changed, but the result is still the same. Okay, we have 1 at each sides. Now let's complete the square for y terms as well. We now have x squared minus 2x plus 1 plus y squared minus 4y. So let's take 4 multiplied by half and then square our results. 2 reduces 4 to 2 and 2 squared gives us 4. So we are adding 4 to both sides. So therefore we have plus 4 equals to 4 plus 1 plus 4. Perfect. So now this is a perfect square trinomial. We can compress it. The root of x squared is simply x and the root of 1 is simply 1. Now whatever sign is attached to the linear term, put it between them and square the final answer. So it has been compressed that way. The root of y squared is y. Root of 4 is 2. Then whatever sign you see here, you put it there. Minus. Then you square that. Equals. So add this up. That gives us 9. So therefore, our radius, r squared is simply 9. And r is simply 3. Or plus or minus 3, whatever. You know, by the time you find the root of 9, you got the value of r. The reason why we're able to figure out our r directly is also because we now have the equation in standard form. And whenever this happens or takes place, whatever we see here is simply our r squared. As you can clearly see that this equation is now in the form of x minus h all squared plus y minus k all squared equals r squared. Perfect. Now how can we figure out the value of the center, the coordinate of center, which is the value of h, k? The center h, k will be, just take the value you see here, multiply by minus sign. So minus 1 times minus gives us 1, and minus 2 times minus gives us 2. So the coordinate of center is 1, 2. So we have everything we need. We can proceed on finding the length of the tangent to the circle. So we know that the square of the length of the tangent, t squared, is simply equals to p squared minus r squared. However, p squared is the distance between C and whatever point is given to us. So let's find p squared first. So p squared will be equals to the distance between this and this. Okay? Let's say, we can say p exactly is the distance, you understand? But p squared, that means we are not finding the square root. Because I don't want us to be repeating square and square root all the time. So just solve for p squared directly. So that's going to be, let this be x, okay, that will be x2, x1, y1, x2, y2. Okay. So we have y2 minus x2 minus x1, that's 8 minus 1 all squared, plus y2 minus y1, 10 minus 2 all squared. So we have p squared equals 8 minus 1 is 7 squared, plus 10 minus 2 is 8 squared. So p squared is simply 49 plus 64. Very good. And the sum results in 113. So therefore we have p squared to be equals to 113. So that's it. Now, in case you might be confused, why am I doing this? Though I explained it at the beginning of the video, but here's the reason why. C is the coordinate of the center, and this is the external point. The line joining them is the yellow line I indicated at the beginning of the video. So we have to find the distance between those two points, and that's the line joining them. So we use the distance formula to find it. Now keep in mind, if you do this to be x2, y1, x2, y2, and this is x1, y1, that won't alter your solution. You have your final answer because there's square there. Doesn't mean. So p squared is 111, and we got r squared to be equal to 9 from the equation. So therefore, t squared will be 111 or 113 to say about minus 9. So t squared equals 113 minus 9 gives us 104. So final answer, the length of the tangent to the circle of this equation from this point is simply the root of 104. And that is our final answer. And that's how to easily find the length of a tangent to a circle from an external point. On to example number 2. Find the length of the equation of the circle 2x squared plus 2y squared plus x minus 2y minus 17 equals to 0 from the point 5, -3. Feel free to pause the video and figure this out yourself. So let's begin. Just like before, we have the equation in general form. 2x squared plus 2y squared minus plus x minus 2y minus 17 equals 0. So now the goal at this point is to reform it into standard form. So whenever coefficient is attached to the leading term, it is first of all recommended to divide all through by the coefficient. Don't bother, they will be the same in all cases. Otherwise, that equation is not the equation of a circle. So 2 reduces this, 2 reduces as well, 2 reduces here, and the rest 2 is still in there. So we now have x squared plus y squared plus half x minus y minus 17 over 2 equals to 0. Now just like before, let's attach like variables with themselves and get rid of constants away from wherever they are. So therefore, we now have x squared plus half x plus y squared minus y equals to 17 by 2. When the negative comes, it becomes positive. Perfect. So now, let's complete the squares. For the x term, the coefficient of the linear term is half. So if I multiply half by half again, and just square it, we're going to have 1/4 all squared. So it means we are adding 1/4 squared to both sides. Perfect. So therefore, we now have x squared plus 1/2x plus 1/4 all squared. Okay. Then plus y squared minus y equals to 17/2 plus 1/4 all squared. Don't forget, never forget, you have to add it to both sides. Always be cautious with that. Now, let's move on. Having completed the x term, let's compare the square for the y term as well. So for the y term, we have y squared minus y. So what are we adding to both sides? Let's see. The coefficient of the linear term of y is 1. We multiply by half and then square it. Notice that we have 1 second all squared. So we are adding 1 second squared to both sides equals to 17/2 plus 1/4 all squared plus 1/2 all squared. Have you considered? Perfect. So right now, we can compress the perfect square trinomials. So the root of x squared is x, and the root of 1/4 all squared is 1/4. And the sign here is positive, we put it there. Thus, all squared plus the root of y squared gives us y. The root of 1 second squared gives us 1 second. And the sign here is minus, we put it there, we square that. This is 1, don't think it's something else. So let's expand this. We have 17 by 2 plus 1/16. When we squared 1/4, we got 1/16 plus 1/4. When we squared 1/2, we have 1/4. So the goal is just to focus on this right hand side. So this is still equals to, so the LCM in this case will be 16 because they are all multiples. 2 in 16 is 8. 8 times 17. We need to use my calculator for that. 8 times 17 is 136. Plus 16 in 16 is 1. 1 times 1 is 1. Plus 4 in 16 is 4. Times 1 again is 4. Perfect. Now the goal is just to add this up. So therefore, final answer for the equation of the circle in standard form would be x plus 1/4 squared plus y minus 1/2 squared equals 136 plus 4 is 140 plus 1, 141 over 16. So therefore, we got the radius, likewise the center of the circle. So therefore, the coordinate of the center of the circle, take this one multiplied by negative sign, gives us negative 1/4. Repeat the same thing for this, gives us 1/2. Because negative 1/2 times negative sign gives us 1/2. So the coordinate of the center is that. What about the radius? Radius would be equals to the square root of this, because r squared is simply the same as this. So do we really need the radius? Let's just use it like that. In fact, it's just r squared we need. So r squared is just 141 over 16. Perfect. Now we need p squared. So what will be p squared? Because p squared is simply equals to the distance between c and whatever point is given to you. So let's be my x1, let's be my y1, and this is my x2, this is my y2. Okay. So therefore, p squared will be equals to x2, which is 5 minus x1 in the bracket of negative 1/4. Keep in mind, the distance formula says that d is simply equals to x2 minus x1 all squared plus y2 minus y1 all squared. If you are looking for the magnitude, then you take the square root. If you are looking for the square of the distance, we leave it like that. Or we are looking for the square of the distance, so we leave it like that without square roots. Perfect. So we close this. Then we had y2 negative 3 minus y1 1/2. Then we square each of them. Perfect. So p squared results in 5 plus 1/4 all squared plus negative 3 minus 1/2 all squared. So right now, p squared will be equals to 5 plus 1/4. Let you see before. If this is divided by 1, 1 and 4 is 4 times 5 is 20 plus 1 all squared. Well, how did I get 1? 4 in 4 is 1 times 1 again gives us 1. Plus, if we repeat the same thing, let the LCM be 2. If this is divided by 1, 1 and 2 is 2 times negative 3 is simply negative 6. The minus, the standard is here. 2 in 2 is 1 times 1 again is 1. Then all squared. So moving on, p squared is simply equals to 21 over 4 all squared plus negative 7 over 2 all squared. Now let's square each of this, but with calculator. So p squared is simply equals to 21 squared. That's 21 times 21. So I got 441 over 4 squared is 16 plus negative 7 squared is 49. Then 2 squared is 4. So let's add this up. If LCM is 16, we have 441 plus 4 in 16 is 4. And we multiply 4 by 49, we got 196. So finally, p squared is 196 plus 441. And I got 637 over 16. So this is p squared. With this, we can find t squared, which is the square of the distance or of the length of the tangent from that external point 5, negative 3. Once we have t squared, we can take the square root of both sides and have the value of t. Perfect. So therefore, since I'm out of space, let me get rid of this. So since t squared is equal to p squared minus r squared, so definitely t squared will be equals to p squared, which is 637 over 16. The minus r squared is 141 over 16. So t squared, if we find the LCM, since they are like terms, we take one of them and subtract the numerator 637 minus 141. So 637 637 minus 141. I got 496. So t squared is simply 496 over 16. So at this point, the goal is to find the roots of both sides. So eventually, the distance or the length of the tangent to this circle from this point is simply equals to the root of 496 over 16. And that is our final answer. If you want, you can let the root affect 16 and have it to be the root of 496 over 16. Or over 4 this time around. The root of 16 is 4. So that's it. And that's how to easily find the length of tangent to a circle from an external point. I hope you find this helpful and understandable. Thanks for watching. See you in the next video. So this is an exercise for you. Feel free to share your solution via the comment section below. Consider finding the length of the tangent to each of the circles shown on the board from the given external point. Thank you. Bye for now once again.